No, I'm really excited to be here. Okay, just so you know, my last international conference trip was London in 2020 in January, right before something happened. I don't know, whatever. But I am so thrilled to be back here. I think I was actually on this particular stage. So I am thrilled to be back in London to talk to you all of today about serverless applications, specifically in .NET. And so, oh, wow, there we go. So a little bit of background on me. I own a software consultancy. It's about 10 of us. It's called Avron Software. We do cloud and we do a lot of .NET. And so this talk is important to me because of those things. It's kind of a bringing together of some of these ideas. And I do all sorts of stuff from web forms all the way up to Kubernetes, microservice management stuff. So we kind of run the gamut. So if you have any questions, feel free to email. You'll see my contact information on the end of the slide as well. Twitter is a good way to get a hold of me. So we'll go ahead and jump right into why I'm giving this talk. So I started out, I'd say about 15 years ago as a developer. And the development experience has always been really important to me. But as I've kind of grown and taken on different roles within my organization, within the companies that I consult for, I've had to shift from kind of small thinking to big thinking. But I've never forgotten that sort of like early on developer make magic happen kind of stuff. And of course, the cloud is a huge part of probably all of our development lives. So I was really kind of interested to see, because of my dedication to one particular cloud platform, you can probably guess what it is, I really wanted to see what other cloud platforms did, how their developer experience was, and also talk and research and understand sort of the cloud offerings that exist today. So this is about expanding my comfort zone as much as it is about education. So for those reasons, I hope you enjoy. But let me start by talking about what kind of serverless is. And I kind of Googled around, tried to find a good definition of what serverless is. And I really like this Cloudflare one, which is it's a method of providing backend services on an as-used basis. So the idea being that, and the idea of the cloud early on was that you didn't have a rack of servers where you were renting out that rack, you were renting out the hardware, and it was just sitting there doing idle some of the time, and you were paying whatever price you were paying for them, regardless of the actual usage of the server. So the serverless ideal was that you paid for consumption. You paid for GPU clock hours used, as well, duration is how they measure that, as well as number of invocations, typically. But it goes on to say, servers are still used, but the companies that get back-end services from a serverless vendor is charged based on usage, not a fixed amount of bandwidth or number of servers. And this one's sort of debatable. I mean, it is, by definition, strict definition, that's the serverless ideal. But like many things in our industry, things have a layer of abstraction that are sort of, that are associated with them. If you're a .NET developer and you use Entity Framework, for instance, that's a layer of abstraction over your database, as opposed to doing straight ADO queries or something, which would be really painful to write, although I do sometimes. So serverless to me has kind of a range of things, because you can provision a serverless thing, but still sit and pay for it whether or not it's actually doing any work. And we'll talk about that through the three major cloud providers. Most people, when they hear serverless, they think of Azure Functions or Lambda Functions, right? Or something along those lines, where you have just like this little piece of code, you just deploy it straight up, and you invoke it or not, and as long as you're not invoking it, you're not using it, the code just sits there. You might pay a very, very small amount of money for the storage of said thing, but otherwise it's just waiting to be consumed and not really being used. Although I would argue that that kind of fits the purest definition of what serverless is. But I would argue things like Azure App Service kind of represent a serverless sort of system. Even though you would pay for it if nobody was using it, you're technically renting it out, you're paying for it. But to me, going back to that layers of abstraction idea, serverless is not just about execution on, and then just calculating your compute, but it can also be just like not managing an underlying web server. I have clients who I manage servers for. I would frankly prefer not to. It's kind of, it's something that I can do. I started out as a support person, so I happen to be good at it. But I much prefer the sort of the cloud abstraction where I'm not having to worry about boy, is that C drive getting full, or something along those lines. So in some ways, things like Azure App Services are certainly serverless. I consider them to be serverless, but for the purposes of this talk, we're going to be focusing mainly on the Azure Function and related product side, as well as containers. So, 3 major cloud providers. When I came up with this, when I started thinking about this talk and what I would do, obviously there's Azure, obviously there's AWS, and I really wanted to kind of think, what other cloud providers exist out there that are maybe not talked about enough, and it would be really interesting to explore the development experience. And I think we all know who we're talking about. That's right, we're talking Oracle Cloud. I once knew I once talked to an Oracle Cloud engineer, this was years ago, and they said, we're the fastest growing cloud provider. And I said, yeah, I guess when you're going from 0.1% market share to 0.2 market share, I guess you probably are pretty fast growing in that measure. I don't think he liked that very much. So this talk is happily sponsored by Oracle. Oracle, please don't sue me for saying that. No, I'm kidding. All right, the joke's gone on long enough. So Google Cloud. And so I have never used Google Cloud before this talk, before doing the research, the many, many hours that I spent working with serverless systems. So it was really kind of an exciting thing, and I won't betray too much, but I think I was pleasantly surprised by a lot of what Google had to offer. So my experience, I mentioned that I use a major cloud provider. I'm a .NET person. A lot of people associate .NET with Azure, and you would be right. That is 90% of what I do is Microsoft Azure. So I want to put that out there in front to show that, well, to give you the benefit of full disclosure. I really tried to put that aside, though. I tried to put that experience aside and just really look for, as a developer, what's turnkey, what's easy to use, and kind of compare them to each other in a fair way. But it's fair to say that I know Azure very, very well. So some of the friction points we'll talk about for other cloud providers, I didn't experience them as much on Azure, or I wouldn't, right? Because I'd be able to figure it out. So that's a thing. But I did try to put that bias aside, but we all know that's impossible. And I have used Azure and AWS in production. I have not used Google in production, okay? There is a local cloud company that I spoke, or not a cloud company, a local company that I spoke to that actually does use Google in production. And I was excited to talk to them, and they said, we love their monitoring tools, and we'll talk about, I went into that specifically thinking about that particular point, but he said, I'm really excited about, using Google Cloud, and they use .NET, and they do React, specifically for, one of the reasons was the great monitoring tools, but we'll talk about that. So I have worked also on entire serverless platforms in AWS and in Azure. The Azure one in particular, we actually did go from Azure Functions all the way up to Kubernetes, and I will talk about that experience as part of the inspiration of this talk. But probably the most biased thing that I can disclose to you is that when it comes to everything, I value delivery over perfection. I don't obsess too much. I generally think, I think this fits pretty well, given what I know at the time. If I know we're fielding 100,000 requests a minute, that's going to very much change how I deal with something where I'm dealing with maybe 10 requests a minute, right? So I often go for best fit, not necessarily the most perfect technical solution. I like to get things done because at the end of the day, customers pay for value. They don't pay for me to be really smart. That's part of what they pay for, but at the end of the day, I need to turn that smart and convert it, that smarts plus maybe a little caffeine, into something useful that they can sell or to save them money. Part of the other reason, many reasons to give this talk, is this is what I feel cloud providers think all of their services do, that there's some little bit of overlap. And I don't actually think, this is kind of a tongue-in-cheek thing, I don't actually think cloud providers think this, but sometimes it feels talking to them it might, because in reality, there's a lot that goes into, like a lot of the cloud services that you use and consume, they have overlap with each other, and it's not always well understood or well known, except by people who are really, really into those platforms, what each of those things are used for, or how they're used, what are the nuance between using Azure container apps versus container instances, for instance. So it's a little bit of a mess. I'm hoping to break some of that down for you, specifically when we talk about serverless. So setting good expectations about, before we dive into the code, dive into all the things related to what this talk is. So it's a good general overview of walkthrough of my experience as a developer And I specifically say as a developer because this is a sort of developer-centric talk, but because I play architect a lot and I have experience with serverless systems and cloud systems, I'm going to talk about it from an architect-y point of view as well. So I'm going to try to give both perspectives, but it's definitely a little more on the developer-focused side. So we're going to discuss two major serverless options. We're going to discuss the kind of classic turnkey, what I call functions, so Google Cloud Functions, Azure Functions, and AWS Lambda. We're going to talk about those, the developer experience around those. We're also going to talk about like how do you grow out of those, right? What do you use to grow out of those? So we'll talk a lot about container-hosted models for functions, for serverless, as a serverless model. So a few things that this talk is not. There's one slide that is in almost all of my talks. This is the substitute for that. It says there's no silver bullet. I never say that there's a silver bullet or one right way. So you're not going to hear me dictate pragma. You're not going to hear me recommend any particular cloud provider. My goal, my job, if I do it well, is to compare and contrast a little bit of the development experience, give you a little taste, and then talk about some of the underlying issues of cloud, really the discussions around cloud, like the really large Venn diagram that you saw, which was a huge mess, right? Where there's a lot of different services and you don't always know which one's the exact right one to use. I'm not going to be dogmatic. That kind of is the same thing, really. And you probably will disagree with some things I say, and I can't know everything because I'm talking about 3 different cloud providers that all have very nuanced ways of doing things in some cases. I'm also going to give you opinions based on anecdotes. I will give you an anecdote warning because I'm a data-driven developer. I'm a data-driven person in my personal life and my business. It drives my wife crazy. Okay, she'll say, you know, I think we should do this with the baby. And I was like, what data do you have to support that? You know, so those kinds of things. I will tell you anecdotes. And if I have an anecdote, I will tell it to you, okay? So you may find that you disagree with the anecdote, that you're like, I've had success with this great thing. Great. My job is not to convince you to go to Azure or AWS, and you're not going to anyways. The companies that you work for aren't going to. Maybe if you're a startup and you're kind of in that early phase of like, what do I do? Maybe, but at any rate. So we will cover in some depth, as much depth as I can do in a very broad talk like this, Azure Functions, AWS, Lambdas, Google Cloud Functions, and Azure Container Functions and the related products in the other cloud providers, or there's Azure Container Apps, I should say. And then by mention only, we will talk about Azure App Service. I will just mention the products that exist at the other cloud providers and talk about what I use them for. TLDR, I use them to deploy like web forms apps or like a giant ASP.NET Core API. Because even if there's unpredictable usage patterns, there's scaling options that exist there to auto-scale that application too. So it's typically what I use it for, is to just deploy. I'll deploy my front end and my back end together. My React apps are pretty much, my React apps with with ASP.NET Core backends, probably going to App Service. There, that's the end of that part of the talk. And then we'll touch on Kubernetes. I will specifically address the impact that I think Kubernetes can have with a little bit of word of warning. So for each of these things, we'll discuss the development experience. So we'll talk about the tooling. How many of you would consider yourselves UI people? So you like to file new project, right-click deploy in Visual Studio? Very few. I like that. Okay. How many people are really comfortable with the CLI? All right. Cool. All right. So there's a lot of pictures of JetBrains Writer and Visual Studio. I did have a choice in this talk, and I went with more of the UI stuff. But I do talk about the CLI, which I think are really powerful, and I really like the CLIs that they provide. I just don't talk about them in depth. But there is a lot of good tooling out there that they provide. TLDR, Azure's is really good for Visual Studio. The others are kind of okay. We'll talk about that. So we'll talk about deployment and the struggles, the specific friction points that I've had deploying or developing. And these, by the way, these functions are not comprehensive. I didn't deploy like a huge cluster that all talk to each other. I tried one function with one specific purpose, and then I looked in the cloud and saw what broke, what didn't, that kind of thing. But we'll talk about monitoring, because as long as we're talking about things like serverless functions, especially if your functions or your serverless things are responding to things like events from Event Grid. You know, something came into Azure Blob Storage, or, all right, talking a lot about Azure. EC2 some file dropped into EC2, and now we got to inform some Lambda to do something with that file, to trigger some kind of process, okay? Got to have good monitoring around, especially as you delve into microservices. It's probably the biggest pain point I've found, besides distributed monoliths, which we won't talk about in this talk. We'll talk about patterns for maturing past the basic functions. And then as much nuance as I can give. My nuance is probably going to follow my experience. In other words, a little bit of Azure nuance, a little bit of AWS nuance, probably not as much Google. I think you already know you can do great things with the cloud, and you can be really creative with one of the things that serverless really promises is a very low cost model if you're within certain parameters, and you can get yourself in trouble. But if you've figured out how to best leverage Azure Functions, like Troy Hunt did with Have I Been Pwned. Specifically, he has this great blog post, and by the way, I will post these slides in the Slack channel. I'll probably post them on Twitter as well, but I'll definitely put them in the Slack channel right after this talk. This is a great article, and I highly recommend you read it. He talks about how he's composed Azure Functions with Cloudflare specifically and caching. Using their clever caching system to run Have I Been Pwned for like a few bucks a month. It's crazy. So some great things that you can do. There's also another article later in here about how he got bit in the ass by huge cloud costs that came out of nowhere. We'll talk about that. So all cloud providers have similar offerings. What do you value? And specifically, what do you value either from, if you're already using it, great. You may go to a company, you may start a startup where you're like, okay, now I got to be the architect for all this. But what do you value? And what do I value? I value frictionless from beginning to end. So we've introduced PHP CEO. That's a real Twitter account, but I'm going to just call him Friction Man, which is just this very charming guy yelling at a phone. And I really like this image for some reason. So when you see this image, this will pretty much be a signal to you that, Spencer encountered friction in this process, or here be dragons, here be potential dragons, as it were. So we'll start with a brand new cloud account for each provider. For all you white hats or black hat folks out there that want to try to, I've already destroyed all the resources associated to them. So you can try to hit them with you can try to hit the URLs and spike my cloud costs or use all my free usage, but it's too late. I already deleted all that. But we'll start with a brand new cloud account. And that's what I did. SpencyServerless@outlook.com. No, I won't check that email address, but I thought it was kind of funny. And then use the following tools. We'll use a Visual Studio Writer, a little bit of the .NET CL, a little bit of each of the CLIs, specifically because my focus was kind of like deploy and then look at what's happening in the cloud, see what if I do X on this particular service, what's the cloud going to say that it did, right? Again, less concerned about doing it all in a CLI or one way or the other. So it was kind of a mix. So it's a really basic thing that I did. I took a function, I deployed it, I ran it 100 times, actually 300, as you'll see in a second, and I saw what happened. So this was my very simple, I dare even call it, I don't even know, will you call it a script? But essentially, just take 100 numbers, and I did 3 requests a second against this thing. And then at the end, I just looked at it. I logged into the particular cloud platform and looked and see what happened. Not really very complicated. Specifically, I had each of the services invoke this particular method. The only thing that I will say about it is that it is highly overwritten, like it feels over-engineered, but basically I had 2 exception types, unfortunate exception and really bad exception. Neither of which had any particular data, and I just basically said 10% of the time throw one of those 2 exceptions. Pretty simple. Not really crazy. Specifically, I wanted to see, again, going back to that monitoring piece, I wanted to see how each of the cloud platforms really treated monitoring, specifically of this particular function, so that I could say, hey, here's my opinion about it. Here are the exceptions. Wow, okay, cool, that's great. Lessons learned. There is actually a lot more nuance, specifically in the cloud offerings, than I expected. Because what I felt like happened is that this cloud provider will come out with this service. They said, hey, this other cloud provider said, hey, we see all these friction points of that service, but we'll create something that kind of abstracts away some of that friction. And then the first cloud provider's like, wait a second, I want to do that too. That's what it feels like. Because again, there's lots of different There's lots of different products that you can use that you can use for serverless that all do really similar things. Again, we'll talk about that. Clouds have strengths and weaknesses. Wow, what a surprise. And there's friction everywhere. Where do you want your friction to be? The way that I'm going to show you that I did it for this particular thing, again, just touching on it, touching on the development models, probably not how you're going to deploy these in an environment where you have 100 different Azure functions or a Kubernetes cluster. You're probably going to have a CI/CD pipeline that builds and deploys all this stuff and runs a bunch of tests. Because we all write unit tests, right? Right. All right, so let's get to the good stuff. Let's start with Azure. So I want to talk about three things, really. Azure Functions. I want to talk about the regular consumption execution model, their premium model, which, again, we will speak on, and then Azure Container Apps as a way of sort of promoting that, promoting your functions to the next level. And there is a good amount of nuance as to why you would use one product over another. The thing I love about Azure Functions, Lambdas, is really creating event-based systems, especially when especially for either if something is processing a file. It's not a business critical operation necessarily, but it needs to process this file every day and then send an email to somebody, some secretary named Spency or whatever in some office that the thing is done, right? Parse through some data or respond and say, hey, I want to kick off a lot of some processes. So I'm going to trigger this Azure function after this file drops into blob storage, something along those lines. So that's what that's my main use case for Azure Functions. Love it for small bits of code that not necessarily, again, business critical, or sometimes they are. And for events, really, I don't use Azure Functions a lot for HTTP. I do occasionally, but not often. And yeah, this is where I think that all of the three cloud providers, that I know, all of their basic functions really shine when you talk about all the events that can happen within Azure as a ecosystem, not necessarily what happens in an Azure function. An Azure function is a means to an end, right? See a file dropped in, we're going to do something with it. It's got a message on this message queue, we're going to do something with that message, right? So it's pretty small, but this is what it sort of starts out as if you go to File, New Project in Visual Studio, as I often do sometimes. Actually, I use a lot of JetBrains Writer, but we'll ignore that for now. So I know it's really hard to see, so I'll just describe that the functions worker is the first drop down, and it gives you some options. .NET 6, .NET 6 isolated, .NET 7 isolated, .NET Framework 1, .NET Framework isolated v4. And you hover over the little thing and you're like, okay, what's the difference between all of those? Obviously the .NET Framework is really obvious, but the Azure function, like what is the execution process? What does it mean that it's isolated? Is that good? Is that bad? And of course you hover over expecting a little tooltip. And you know some product manager was like, I know exactly what this tooltip's gonna say. It's gonna say the Azure Functions worker to use and people are gonna understand. Again, I tried to approach this, I know what those are, but I tried to approach this as if I didn't. So I just thought that was kind of funny. A little bit of a friction point, tiny bit, really not big in the long run. But then you get a huge amount of triggers. And again, triggering off a service bus, off of some kind of storage queue or something along those lines. HTTP, you name it. There's a huge amount of different triggering options in all of the platforms. None of this is probably new to you. And so you get there's a bunch of solutions on the side, but you get this one that is just a function file. The thing that I will point out, because I'll make it just a little bigger, is the static class. So it starts you off as a static class with a static run thing. So right off the bat, you're going to look at that and say, okay, well, I like ASP.NET Core, I like dependency injection, or maybe you don't. I don't know. I like those things. You're like, okay, how do we make that be with dependency injection and all of those niceties that we have? So a very simple model. So it's kind of pretty much, oops, let's see, go back one. You define a startup class that inherits from function startup. You write a configure method, you can add your services to that, and then you just attach it to the assembly. Azure function reads that as like, cool, this is something that needs to run as the function is starting up. So we'll go ahead and run it. And then the thing I didn't do here is convert it from a static class to a regular class so I can take advantage of the dependency injection. But I started here and I was just like, all right, I'm just gonna see what happens. So I deploy it, right-click and deploy. Again, not something that I do in my day-to-day, except as somebody who's just experimenting, somebody who's just trying something new. So right-click publish, and it's probably not going to be any surprise that that it worked, and it was really pretty seamless. I had some other dialog boxes like, hey, what resource group do you want to call it? Some things that you need to know if you're deploying to the cloud. What region is it going to be? So skipped over that. But by and large, pretty easy, straightforward process. And then I get there and cool, I'm looking at it in the cloud. Why isn't it starting? And I see this little thing up here. Thumbs up. This method or the operation is not implemented. Immediately right away, I went back to my function startup and realized I didn't take out the stupid throw new not implemented exception. So good. Anti-friction, because the cloud told me exactly what was wrong as soon as I deployed it, which I really enjoyed. And then, so I converted that to a class, again, ISUM service, very simple, just injected the concrete implementation of that, and then I just let it go, right? Let it see, get post, doesn't matter, I'll just pull it out of the query, the name out of the query string, and then I'll run that thing, and hopefully 90% of the time it will work. And 90% of the time it would work, as predicted. And so I wanted to see what happened on the other end. What happened inside of, what does the cloud say happened? So right out of the bat, if you're familiar with Azure, probably should have asked this. How many people use Azure on a daily basis? How many people use AWS, Google Cloud? Okay. Well, you know Application Insights well, at least half of you do-ish. You know that right out, you get a lot of good comprehensive data, information. You can see right away that it immediately signaled my failed request. Of course, you can set up alerts around that. They all have very similar offerings and products, and I would argue some are better than others. And I would say that Application Insights is pretty, in my experience, is pretty middle of the road. There's a product that I do use, but I find it difficult to navigate and difficult to find systems that are connected. It's sort of, it can be difficult unless you instrument them really well and you're really intentional about it. To find things within Application Insights. It's also really expensive. That's the thing that people talk about when they talk about Application Insights compared to the other two cloud providers. You get cool things out of the box, but it's also very expensive to ingest all this data. But right away, I was pleased as a developer, again, very surface level. Starting off, I was very happy that I got a count of failed requests, the number of requests that came in, and the breakdown of how it looked from the server side. So I clicked failures. I wanted to see, what I was really looking for was something along these lines. Really bad exception, unfortunate exception, a little breakdown. And then more information under that I can click through and kind of maybe sense a pattern. These are tools that I use a lot. So again, I'm very comfortable with them. I knew this was probably going to be like this. But again, going back to, you get this not with Azure Functions. They just deploy it for you unless you tell them not to. They deploy you Application Insights. So little cost thing that you should be aware of. The clients of mine that log literally everything down to traces in Application Insights and then just crank sampling all the way up to like they're only sampling 4%. I think South Park guy said it best. You're gonna have a bad time. You're not gonna see anything and you're gonna pay a lot of money to not see anything. Great. So comprehensive goodness out of the box, comparatively expensive. I prefer Datadog if I had a choice. Datadog is one that I think is a really solid product. I think it's reasonably priced. And that is what they do. That is all they do. Again, this is just one recommendation of one person. There's a ton of cloud monitoring products that exist out there. But I personally like Datadog for the ease of finding things and the money that I'm spending. But Application Insights is a good product, pretty turnkey. So, talking about the execution paths for Azure Functions. There's in process, which runs inside of one process, and then there's isolated, which doesn't run each function inside of one process. But there are nuanced differences between the two. There's an article, again, all these links, all the slides. I see people taking pictures. Take pictures, of course, but I promise I'll put these slides in the chat. You can click through. A lot of good documentation. One thing that Microsoft Azure excels at is really, 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 really good documentation. Like industry standard, in my opinion. This table is ripped straight from there. I'm not going to go over everything in great detail, but they both support dependency injection. One has a slightly different development model of what of their request response model, but there is not stuff in all of them. Specifically, I ran into a case the other day, which I'll talk about in a second, where isolated is where Microsoft is going. Next slide, that's where they're going. This is a thing straight off of a Microsoft blog. They say in process is being phased out. And we're going to go on, we're kind of going to have it for .NET 7, kind of sort of, and then we're going to go on to .NET 8, and in process is going to go away, and isolated is going to be the new cool thing, which is all well and good. But there are nuance, again, going back to that nuance concept. I had a situation the other day where I had an isolated function. It actually started as an Azure function and was promoted to Kubernetes using pretty much the same development model, which is really nice. One of the cool things about these platforms is that you can take something that you've developed in one and then just port it to a container and then just execute it that same way. It's really handy. It's really flexible. But I'm like, hey, I know that if this service throws this particular exception type, I shouldn't follow any of my retry rules because it was an Azure function. I was listening on a message queue and it was configured to retry 5 times. That's all well and good. Things should retry because of transient errors. Not unheard of, very typical. But I said, hey, but the tools that would allow me to just send it straight to the dead letter, they don't exist on isolated. So I tweeted at this guy because I was Googling around trying to figure out how to do this. And he's like, yep, pretty much you can't do it yet. Here's the epic. If you look, I don't have a link to the tweet. I need to put it there. But there you talk about a friction point. That was just kind of annoying more than anything. But it's TLDR. You just can't do it. I had to just swallow that exception and just either pretended to process. Either the choice was swallow the exception, pretend to process, crank the retries down. Just was, again, you're going to have a bad time. It happens sometimes. So there's pain. There's some pain. There's an epic that's tracking the development of that. It's the kind of things, the kind of nuanced, like little friction points that just kind of make us suck. So I just commented out the code and I said, hey, uncomment this code when this thing happens. Somebody's totally going to read that as soon as that epic is closed, as soon as it's going to merge in. It's going to happen. Or we'll put it in the Jira backlog. It'll get looked at eventually. Something to talk about. I talk about serverless as if it's a good thing because it is a good thing. The one thing that everybody talks about when they're talking about AWS Lambdas, Azure Functions, Google Cloud, cold starts. That is probably the biggest struggle that most people have with it if they're trying to create not necessarily highly available, but like highly responsive systems. Cold starts are a thing, whereas the first invocation, they have to literally warm something up to actually handle that, and that includes executing your startup code. Startup code is the being able to have dependency injection in startup as a baseline is overall a good thing, but it can bite you in the ass if you choose to run a lot of stuff within that startup code that would make your cold starts time even longer, and that's bad, right? Because that's just going to, but there's ways around that. You can move on to something like Azure Functions where you have premium plan on Azure Functions where you have these pre-warmed instances where you're able to mitigate some of those by having services that are immediately available to respond to your requests. But there is a minimum spend required. Here's what it looks like inside of the Azure portal. It said, hey, just to have this thing existing, $157 a month. So this is where we get back to the layer of abstraction idea, where we have this thing where the promise of serverless is that we're only paying for compute, but now we're not paying for compute, we're paying for a server to sit here. Again, that layer of abstraction idea. We know that there are servers under the hood, we're not managing those, but now we are still paying to have us be guarded against cold starts, as it were. But it is one option. It also does come with nice scale options so that you can say, here's the maximum number of instances that you can burst or put out at any one time. And how many instances do you want always ready to start to respond to requests? Depends on your traffic flow. It depends on a lot of things. So it does give you that flexibility. Again, going back to what it is when we talk about it being serverless, there you go. You're not managing the underlying servers. You're just asking it for instances and it's giving them to you. And all you're doing is paying for them. Azure Container Apps is kind of a next natural step. You could even consider it a next natural step after Azure Functions to skipping straight from basic consumption to skipping premium to going to Azure Container Apps. Because you get a more flexible hosting option, but less spend during idle periods. So you kind of get the best of both worlds. Your spend is lower, you're still paying for something to exist and something to be there, but at the very least, on the other side of that, you get to enjoy a lesser spend, but still have that demand available. Kind of best of both worlds. So, excuse me. This particular article, I really enjoyed it. This person, anybody, if you are somebody who writes a series of articles saying, hey, here's what we did to transition from here to here, and here's all the pain points that we saw along the way, that's this guy. God bless him. I love that because you get to see all the little pain points, all the little things, all the developer friction that we experience. So this article was great. And he describes why Azure Container Apps were a good fit for him over Azure Premium Functions, which they said worked for a time. There's a potential advantage over Premium Functions plan. The notion of the containers becoming active, even though they're still provisioned, but idle, costs is lower because they're just sitting there kind of waiting. I guess it's like a idling Prius as opposed to an idling, F-150. So this kind of goes to this concept that I have of cloud growth. I called it cloud maturity at first in my head, and I was like, that doesn't really seem to fit, right? Because, Dapper, which is a great data access library for .NET for accessing SQL databases, was written specifically because Stack Overflow found that link to SQL, which is what they were using to do queries, was too slow for them because they were executing so many queries all the time. It was actually too slow, not because of the SQL databases. I'm sure they had problems there too, especially with John Skeet. There's entire articles about how John Skeet alone caused them to have to re-engineer a bunch of stuff because he has so many answers and so many likes on his things. But beyond that, they had to deal with the database stuff, but they also just found that their web servers were constantly spinning, constantly hot because Link to SQL was cooking these queries, right? So they wrote Dapper because, as Sam Saffron said, we measured, found the bottlenecks, and we fixed the ones that mattered, okay? That's the kind of the same thing here because you can go from Azure Functions, find, and I've had clients that did this, find that the spend or even the response time wasn't sufficient as their business grew. I do kind of specialize. I work with big companies, but I've worked for startups and I've specialized in scaling startups. You could say that. Or at least I'm good at understanding the problems that are associated with startup scale, the technical problems specifically. The people problems, it's a little bit beyond my pay grade. Those make the technical problems look like nothing. But had the situation where they're finding that Azure Functions was really expensive. Their compute was really expensive. It got them started, it got them off the ground, but now they're outgrowing it. So that's what I mean by cloud growth. More like cloud outgrowing. I don't know, it doesn't really roll off the tongue. But you could do something where you're transitioning from Azure Functions to Azure Functions Premium to container apps, right? All the way up to big, scary Kubernetes, okay? In this particular client's case, they went straight to Kubernetes, which was a decision. I'm not saying it was a bad decision. I'm just saying that I think that there were costs to it. I think they overestimated the complexity of Kubernetes because, yeah. I have people that do Kubernetes for me. That's all I'll say about my experience there. But recognizing as an architect, okay, as the value at the value that Kubernetes can provide and all these other cloud services, that to me is the more interesting question and helps me make much more informed, better decisions for clients. So, Azure summary, great for small bits of code to respond to events and for starting out. HTTP, if you can deal with the cold starts, you can certainly field HTTP requests with it. Azure Functions Premium, as we mentioned, it gets those cold start problems out of the way. This app, again, one of the things I love about the cloud is the creative ways that people use to actually kind of work around some of these things. In particular, this article that I have linked here describes how he wrote something to basically spin up a premium instance when traffic started to get a little escalated on the consumption plan. They'd spin up the premium instance, handle all the traffic, especially if it was unpredictable, bursty sort of traffic, where they didn't want those cold starts to really impact them, and or they knew that the consumption plan, they'd start to pay more for execution, and then they'd write code to spin it down, and then just go back to consumption, because consumption, pretty cheap if you do it within their parameters, if it costs you anything at all. So that's a really interesting article. When I post the slides, I encourage you to read. through some of these. I think they're really interesting. Again, creative use of the cloud is something that I think is really awesome. Azure Container Apps gives more flexibility for building scalable apps, as we described, especially as compared to Azure Functions. You could skip Azure Functions and just deploy your apps in Azure Container Apps. But if you have a suite of existing functions and are starting to have growth problems with it, either with execution or whatever the case may be, that's certainly a tool that we can use. And then App Service, as I mentioned, I just use it to deploy boring old web apps, ASP.NET, where there's not a lot of, there could be compute problems or traffic problems that I can easily handle with scale out or things along that line. But typically it's just kind of boring old ASP.NET Core apps. And I found that that works well for me. So let's talk about AWS. Let's see. I told myself I was going to give equal time to all three of the cloud providers. We got, what, 20 minutes left? All right, we'll see what we can do. So serverless and AWS, we have Lambdas. We have serverless Lambdas, which is slightly different flavor, which we'll talk about. App Runner and Elastic Beanstalk. I will tell you that I did the Lambda development experience part. I did not do any of the container stuff inside of AWS. But we'll talk about the kind of the parallels between all the cloud platforms, right? So I will say that my overall impression of AWS is that their tooling was a struggle and that their backend is a struggle. As somebody who, again, I know there's AWS people in the cloud, and you're probably looking at me like, hey, well, if I can figure it out, certainly you could too, or you're an idiot. You're the guy on stage is an idiot, not you. That's probably true, but this is not something that I find that is an uncommon story. Anecdote warning, this is something that lots of AWS developers have expressed, but I understand once you're really good with the tooling and once you really understand it well, you can make some good money as a consultant, that's for sure. So .NET New, Amazon Lambda templates get a huge series of templates, and additionally the deployment tools that you can use that to help your development experience along. I did not use this. I think I might have used this command for a couple of things, but it exists. I did install the AWS Visual Studio plugin, and I was pleased to find that it was pretty much like the Azure one, which was cool. And starting out running a function was pretty straightforward. I was a little bit surprised that when I first started doing this about 1.5 years, 2 years ago, when I had a client that did a lot of Lambdas, that this was my method of execution for a local Lambda function. Okay, I can manage that, although I much prefer using another tool, which if you can do it that way, I didn't bother figuring it out in time for this talk, but it was a little weird, but it was workable. Pretty much akin to the experience that I had before. And then, as far as wanting to deploy it, I wanted to just simply right-click publish, so that's what I did. They said, here, give me an access key and a secret key. So I went into IAS and created a user and hid the key. Why, I don't know, because I guess for extra security, but I already deleted that user a while ago. And that's when I got my first taste into IAS, or as I like to say, IAS. I found it to be as somebody who knows very little about it, I found it to be frustrating to say the least. I felt like Google Cloud's tooling was a lot better in that way. But I finally was able to Google and find this random GitHub issue where I was able to find, okay, here's all the things that the test user needs, all the permissions that it needs. But actually this one was a little newer, and that's the one that you actually need for whatever reason. So I didn't, again, spend a lot of time figuring this out. My point was just to figure out the friction one way or the other. And then I got my function. Okay, it doesn't support editing in the .NET 6 runtime. Okay, small little bit of friction. I could deal with that. It's not really that big a deal. And then I can create a URL with an auth type of none. And of course, I was really excited, plugged it in, and internal server error. And I could not get past this for this particular function or Lambda deployment. No matter what I tried, and I tried Googling. I even talked to the AWS expert in my company and another guy who works at AWS, and he said, just try redeploying it. And I was like, all right, well, I'm not going to do that. I'm going to redeploy a new one. So I ended up creating an AWS Serverless Lambda, which adds a little bit on top of AWS Lambda. And that worked fine, except, oh yeah, I've got to make sure to add the permissions. It didn't work the first time, so there you go. IAS had to figure that out again. And then I got this. I finally got a lot of greens and yellows. The yellows never changed to green, if that's a good thing or a bad thing. Again, probably not going to use Visual Studio to develop AWS apps. I'm actually would use Writer or probably the command line or therein both, but even more than that, I'll probably use another set of tools, which I'll mention briefly. But the thing I liked about this is that, and sort of good or bad, is that this CloudFormation template came with that, and that probably looks very familiar to you. I understand that in AWS, the AWS project that I worked on, they relied heavily on CloudFormation templates, which are really useful. It's just they're also very nuanced and not something that I understand super well. I understand what they are conceptually. And in fact, the only demo I have, because you see I have a lot of screenshots because I never count on demos, especially since Azure was down this morning, I was vindicated. I said, you know what, I don't want to even write these things. I'm going to just ask ChatGPT to do it. So I asked it to create me a CloudFormation template for an AWS Lambda that'll be deployed to 5 US regions. And it spit out something that was JSON. And then I was like, nah, I'd prefer it in YAML. I actually do prefer YAML for these, even though I don't like YAML. And it worked pretty well. So I felt like if I were to go into this, ecosystem more, I'd probably invest in some AI tools to help me with that generation of those, at least as I was getting started. So I did finally get it to work. That worked, I assume because it created an API gateway, and then it spoke to the Lambda, or sent my request to Lambda, which was great. And it even had this cute little calculator controller example that I was able to get to work the first time. I added 1 and 2. That was cool. And then I looked at and then I decided to look at their CloudWatch metrics, which I had to deal with some of these things when I worked on that AWS project last year. I did have to do some debugging in production, and even the AWS guys at the company were just like, you'll find it eventually, and I did find it eventually. But my particular favorite thing was that I invoked the thing 300 times as I expected, and it said I had no errors. Even though, what are the statistical chances that 300 times, 90% of the time it's supposed to fail and it doesn't have any failures at all? Please. Whatever. I went into the logs and sure enough, there were exceptions, but they were all on different lines. And you as an AWS folk out there probably are like, yeah, I know, idiot. I know exactly what to do to fix this for you, and it's this. And I'm just like, yeah, I know. And it's probably, please come after me after the talk, either validate or punch me in the face, like one or the other. Like I really want to know if this is common, because I don't use AWS a ton. I'm just tell you right now. So that was their cloud monitoring. I wasn't impressed, but I maybe wasn't doing it right. Other hosted service, AWS Elastic Beanstalk, which is kind of akin to Azure App Service. This is the anecdote warning that I'm going to tell you. Everybody that I talked to about AWS Elastic Beanstalk said they hated it. They didn't like it for reasons. One person particularly said that it was hard to configure HTTPS. Now, I don't know when that was. It could have been 5 years ago. But I have not heard anybody say anything positive about it, especially talking about it from a perspective of using it to execute .NET code. Good, bad, or ugly. And I'd really love for you to come up after the talk and tell me, oh, actually, we only use Elastic Beanstalk, and it works perfectly for us. I genuinely would like to know, because I've only heard bad. So come up and tell me if there's good. And then this is where we get into the idea or the concept of all these different products that do very similar things, right? So AWS App Runner specifically is sort of their newer product. It's akin to Google Cloud Run, akin to Container Apps, which is a more managed container execution platform. Whereas Fargate is a little more bare metal. It gives you less stuff on top of it, or it's more, you have to configure more stuff under the hood. You have to configure networking more. So again, going back to those layers of abstraction. I didn't dive too deeply into this, but my general conclusion was that if I were to look at this and use it, I would probably look at App Runner very closely. And then, of course, there's Kubernetes service if you choose to use Kubernetes, which you may or may not. So there's probably no surprise that Lambdas are pretty much like Azure Functions, but it's the AWS flavor of them. And then if I were to do Lambdas for sure, I would absolutely invest time and energy into learning the CloudFormation way of doing things, which seems to be the quote-unquote right way. Or beyond that, because we've kind of talked about these, App Runner and Fargate, this is another article that talks about the great nuanced differences between the two. Again, I thought that was really useful, and I love things like that. Well, you already know my opinion on Elastic Beanstalk. I didn't use it myself, so again, I'm only telling you this is third-hand information at this point. So I will say that the honorable mentions for at least addressing cold starts for AWS Lambdas are provision concurrency. The problem is it's expensive for what you get, $3 a function a month, which adds up very quickly. Or you can do the Jeremy. The Jeremy is a consultant of mine, and he literally has a function or a Lambda that runs every 10 minutes that sends a request to the other Lambdas to just keep them warm. And he said, those executions cost nothing, so I'll just have this thing just keep them provisioned, so that way I just mitigate cold starts, and it's a lot cheaper than provision concurrency. He also says he uses something called Serverless and AWS Vault for the majority of this stuff. This is projects that I do not architect because Jeremy is really good at what Jeremy does, so I let him manage all that, and he's very happy with the stack in general. So I just let him go for it. So last but not least, absolutely Google Cloud, which was the most surprising of all the three in terms of what I found. I found it to be a really pleasurable experience, and let me talk about that. So Cloud Functions, of course, Cloud Run, which is sort of their higher level container abstraction, again, akin to container apps in Azure. And then App Engine, which is like their app service, which I didn't hear one way or the other because it actually was kind of hard to find Google engineers to talk to, Google Cloud engineers to talk to, believe it or not. I did end up, once I figured out I had to install their CLI, I did end up installing the toolkit, the extension into Visual Studio, and I got a couple of templates that I can install from, and I hit next, and then I tried this, and then I saw specified method is not supported. Okay, I guess it is what it is, not the worst thing. So I consulted their docs and found this one I thought was particularly amusing. Make sure you're on a Windows machine with Visual Studio 2015. Not surprising. I'm going to assume that of all the Google Cloud customers that .NET is probably niche for Google Cloud, but at least they do support it. I mean, they do have John Skeet after all. I would expect that. So I ended up going back to just straight old .NET command line, which is usually what I do anyways, that or Writer. And once I had the templates installed, of course, they just showed up in Writer, and I started one. And I was really, well, I wasn't that surprised. It was actually really well commented, really, really thoughtfully done APIs was my first impression. Pretty much the same startup model. They have a function startup just like Azure does. And that was really easy to use. I don't know what to say. We use the same attribute at the top to the assembly level attribute to define that this is the startup that you're going to use. And then it pretty much was exactly very similar to Azure Functions in terms of the development experience. Here it is a little bigger. Not really that surprising. It doesn't implement HTTP function because it's an HTTP listener. Of course, there's other listeners that are available for all the other listening products for whatever it is that Google uses for blob storage. And then I decide to, hey, well, this is a template, so I'm going to look here and see what do I get out of the box to deploy. And I really wanted to deploy to Cloud Function. So really wanted me to deploy to Cloud Run. So that's what I looked through their extension, and this is Writer, by the way, at this point. I forgot to say that I did switch over if it wasn't obvious. And I was like, well, where's just deploying to Cloud Function? So it's the tiniest little bit of friction. It's not that big a deal because, again, I'm comfortable with the command line. And this is, my general impression is that that's where the tooling wants you to go anyways. I think that that's a ecosystem thing throughout all of development, is that somehow we've made our way from command line to GUI back to command line. So I was like, cool, I'll figure it out. And I was able to deploy it first time after I installed the gcloud CLI and then authenticated, it was actually rather straightforward to get to. So that's what it looked like. Not much to it. Define my project, define what it is, HTTP function, and push go. And then I did originally try to put my sum service in a separate library, but the docs say, got to push it up as a NuGet package because it's actually using Cloud Build, I think is what it's called, under the hood to actually build it, and it really doesn't want you to have that in a different project. And I was like, fine, whatever, I'll just stick it in the same project. Most of the time, that's what I do anyways, or I consume a NuGet package, so I was fine with that. This was the thing that I was most impressed about Google, is that the monitoring out of the box, the guy said that the monitoring was good, and I agree. I tend to agree. It's honestly like better application insights, more akin to Datadog than anything. Datadog is a pleasure to use. I would say this monitoring was a pleasure to use. Obviously, it gave me a huge amount of metrics. It did not put all of the different logs on a different, it didn't say the line break was the log delimiter. So it did actually combine all of these things. So I was able to easily find the exceptions that I was thrown. I was able to see when I dug into that specific exception, here's all the times that it was thrown and view the logs under therein. And I really enjoyed that not only did they type the query for you, which again, pretty typical, pretty much what you get in Datadog, and to some degree Application Insights kind of does generate a little bit of the query for you. You can at least send it over. But I generally speaking was very happy with what I was able to kind of see and what I was able to observe using this, which is a powerful concept because in microservice systems, observability is a make or break kind of thing. In order for high reliability systems, you need to be able to observe when things go wrong. So I was impressed. This is nitpicky at best. It doesn't support .NET Framework. Wah, wah. I guess I won't be able to deploy my web forms microservice. My first microservice was written in .NET Framework, though. And not as widely adopted as the other cloud providers, duh. I mean, we know that. I don't know any Google Cloud engineers very closely, very personally. But network effect is a thing, right? The more people that use AWS, the more people that use Azure, the more people that use Google, the more people that use React, .NET. Those things get value as more people use them. So it's a real thing. But I say it's nitpicky at best because I think their docs are pretty good. Certainly the experience was very frictionless compared to IaaS, whereas Google Cloud was like, hey, your authentication doesn't support Google or Cloud Build. Do you want me to do that for you? And I'm like, why? Enter. And it was like, we did it for you. I was like, okay, that's pretty cool. That's like, you could just tell that they were very thoughtful about their tooling, and that really impressed me. There's something else really cool. shell.cloud.google.com. This was something that I talked to a person who works at Google as one of their advocates. So they pointed me to this, and I was really impressed with what it is, which is pretty much a cloud shell that you can use to manage, that you can use to interact with Google Cloud services. But more than that, it does have some compute behind it. I'm not saying it's the fastest thing in the world, but I was able to, it gives you like 5 gigs of storage or something, and I was able to create and execute and run some .NET projects. So tip of the iceberg kind of thing. I don't know of any cloud provider that provides something this cool that anybody can use without a Google Cloud account. So I was very impressed with this. It's at least worth messing around with, go into it. It doesn't cost you anything. You have to hand Google your login. They already know everything about you anyway, so what's the big deal? So, Cloud Functions, big surprise. Similar to Azure Functions and Lambdas in pretty much every way. Kind of have the same capabilities, right? They fit within that Google ecosystem the same way that Lambdas and Functions do in their respective ecosystems. Cloud Run seems to be the kind of container management solution that they use, as opposed to AWS and Azure that have a few different ones that are kind of similar, that kind of solve different things, which is fine. But it's but they seem to have, I don't know if their products are just simply more condensed, for want of a better term. And then there's App Engine, again, generalized hosting akin to App Service. Did not try that. Same, I didn't try Elastic Beanstalk. Detailed cost comparison of functions versus run. You can find this. This is a really cool, another really detailed documentation because article that somebody wrote. Those kinds of things are kind of comparing apples and oranges, or apples and pears, because they're both stone fruit, but they're kind of different, right? So this was an interesting take, and they kind of break down the nuance of why it's kind of hard to describe. All right, it's time for the conclusion slide, and we got 55 seconds, so let's go. Right, so most of your cloud providers are going to have been chosen for you already. I think we already know that. We already, based on the raised hands, we already know that to be the case. And your architecture, in my opinion, should only be as complicated as it needs to be. I would never advocate for somebody who's going into microservices to immediately jump face first into Kubernetes, because your face first is going to end up being a concrete bottom. It's going to be a pool without any water in it. My bias, again, is always getting stuff done versus overcomplicating the architecture. The architecture can be improved, like unless we're talking, it depends on the stakes that we're dealing with. But generally speaking, I've always found that early delivery just is better than everything else. And of course, this is pretty typical of, we've worked in the cloud. Cloud costs can get out of control and you can lose your shirt sometimes. This happened to Troy. He talked about the cloud almost a year ago to the day. I think it was yesterday. A year ago was this particular article, and I thought it was a really good one. It was a really good framing of the problems with some cloud solutions. Azure Functions, AWS Lambdas, stuff like that for event-driven stuff is absolutely the game that I have to play. That's where their strengths lie, in my opinion. And all cloud providers, pretty much all of them have a model for taking those functions and putting them into a container, and then putting them into a more elastic container service with better cost flexibility, really with better execution flexibility at the end of the day. And so, like, in particular, my case study is that they moved straight from functions to Kubernetes and cut their cloud compute costs by 80%. And they were processing a lot of files. So there's serious gains to be made. Do I think that they could have done this in container apps? Absolutely. But they made a choice, and it's worked out long term. It's worked out well for them. This is the part where I say something about slide complexity, but because I'm a minute over, or cloud complexity, we've already kind of talked about that. I do have a little handy table that was like, okay, you want to do one thing or another, here's basically the thing that you could use, the thing that you should look into, the thing that you should Google. Again, I'll have it in the Slack. I see somebody taking a picture. All right. And then bottom line, I leave you with another article that I thought was useful. I didn't know where else to stick it, which is Serverless Showdown from acloudguru.com, which is a fantastic cloud resource. And then there's lots of links throughout the slide deck, which you will get a copy of. If you have any questions, I'll be around at the conference. Thank you very much. Enjoy the conference.